Hi, welcome back to Chemistry Clubhouse. Today we're going to talk about dilutions, major component of anytime you're working in a wet lab. So, what we're going to be talking about is the idea of we are going to take a molarity, and what we're going to do is we're going to take that molarity and we are going to dilute it. All right, and what that dilution is basically taking some concentration, taking a concentration and adding water to make it less concentrated. Hence, dilute. All right, so if we have a solution, that, say, has 10 particles in it, 2, 3, 4, 5, 6, 7, 8, 9, 10, all right, and we have that 10 particles, and then we add in water, what that's going to turn into is this exact same number of particles, but now my volume increased. So we still have those 10 particles. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So again, we have 10 particles here, and we have 10 particles here. The difference is this has small volume, and this has a large volume. All right, so again, if we look at that, m equals n over v, our 10 particles remains the same, but our volume is changing, which means our molarity, as I increase that volume, our molarity is going to go down. So let's look at our first problem. All right, so we have 25 milliliters of distilled water is added to 125 milliliters of a 0.15 molar NaOH solution. What is the molarity of the diluted solution? Now, there's two ways of doing this. Now, in my class, we were talking about the idea of let's do the givens. So we've got our volume 1 is equal to 25.0 milliliters. That's actually wrong. That is not our volume 1. Our volume 1 is actually 125.0 milliliters. Our molarity 1 is equal to 0.15 molar of NaOH. Now, it says in the problem 25 milliliters of distilled water is added to 125. So that means our volume 2 is actually 150 milliliters. Okay? And what we're looking for is M2, which we don't know. Now, showing my class that if you notice, the number of moles isn't changing, just like we showed in the last one. So if we look at these equations, we can set it up as M1 is equal to N over V1. Which we have. We have M1, we have V1, and now we can solve for that moles. And then M2 we don't know, but that N is going to remain the same over V2, which we now have that 150. Well, we can set this up a slightly different way. M1 times V1 is equal to N, and since those N's are equal to each other, M2 times V2 is also equal to N. And if we simplify that, it's M1 V1 is equal to M2 V2. So there's multiple ways of solving this. I'm going to show the way that I learned back when I learned this. I did it the long way. M equals N over V. And I plug everything in. 0.15 molar is equal to N over 0.125 liters, because again, it has to be in liters if I'm going to use this equation. So I've got 0.15 times 0.125, 0.15 times 0.125, we get N is equal to 0.01875 moles of NaOH. All right, because that's the same, and again, that's 1 and 1, M2, which is what we're looking for, is equal to N over V2, which is equal to this same number of moles. This moles didn't change. So we have 0.01875 moles of NaOH all over V2, which is 0.15 liters. And if I divide that by 0.15, we end up getting AM2 is equal to 0.125 molar NaOH, which makes sense because it went from 0.15 and now it's diluted down to 0.125. So that is my correct answer. Now, we could also do it that other way. All right, if I shrink this a little bit and move it up, and we do M1V1 is equal to M2V2. It's a little bit easier. All right, we don't have to change the volume to liters. We can, which we will here, but we could leave it in molarity because they're going to cancel each other out because they're on opposite sides of the equation. So I have 0.15 molar times 0.125 liters is equal to M2, which we don't know, and 0.15 liters. And if we just do basic algebra, we have 0.15 divided by, or times 0.125 divided by 0.15, we get 0.125 molar NaOH. All right, now, same answer, just different way of doing it. All right, if you notice, it's the exact same calculations. One's just kind of multiple steps, and one's just plug in. Your choice. I've always liked doing the upper way because it just, in my head, it just made sense. And you make it work for you. All right, here's another question. So I've got this stock solution. I'm going to draw a picture for this one. So I've got a stock solution. All right, that stock solution. This is a 5.0 molar solution. All right. And what we're going to do is we need to make, in a flask, we need to make 150 milliliters of a 0.3 molar CuSO4 solution. All right, the question is, how much of this do I need to put in here and then transfer it into here, and then how much water, all right, so how much H2O needs to be added with it. Okay, so I've got a 5 molar solution of CuSO4, and that 5 molar solution of CuSO4 has a certain, we need some of it. We don't need all of it. We need some quantity of it. All right, that's going to be this right here. That some quantity is then going to go down here. So that's going to be here. And then we're going to add that water up, continue to add water, and then our water will the water that we take from here will then be here, and this will be our diluted solution. Okay, so that's the thought process that goes into this. We need to figure out how much of this and how much of this need to be added together. Okay, but let's write out our givens. We have M1 is equal to 5.0 molar. That's our stock solution. We do not know how much of this we need. All right, our M2 is 0.3 molar CuSO4. Let me add that up here, CuSO4. And our V2, the volume that we're going to make, is 150 milliliters, which is equal to 0.15 liters. All right, I'm going to do the shorthand way here. So, again, I've got that M1. M1V1 is equal to M2V2. All right, so we plug in M1, and we've got 5.0 molar. V1 is equal to M2, which is 0.3 molar, times 0.15 liters, and our V comes out to be 0.3 times 0.15, divide that by 5, and we get 0.009 liters, which is just 9 milliliters. All right, so that answers our question. We need 9 milliliters of our stock solution. Okay, so, if we need 9 milliliters of our stock solution, well, what's the water going to be? Well, it's 150 is our total volume. That's what we need. That's going to be equal to some amount of milliliters of H2O plus 9 milliliters of H2O, which means we're going to need 141 milliliters of H2O. That is going to be what we need. So how are we going to make this? Mix 9 milliliters of a 5.0 molar CuSO4 solution with 141 milliliters of distilled H2O. And that is how you would make that in the laboratory. All right, one more problem. So here's a challenge. A sodium fluoride solution is made by dissolving 125.6 grams of sodium fluoride in enough water to make a 1 liter solution. If 180 milliliters of the solution is removed and diluted to 500 milliliters, what is the molarity of the diluted solution? This is a great question. All right, it's actually multiple parts. So let's get started. Let's write down our givens. So we've got our mass, our mass equals 125.6 grams of NaF. All right, and we're going to make a volume of 1.0 liters. All right, that's our first part. So let's make our first solution. Okay, so we need to know what our N is. N1 we don't know, and our M1 we do not know. All right, so here we go. We have to do a little bit of dimensional analysis to get this moles. So 125.6 grams of NaF times 42, approximately 42 grams of NaF for every 1 mole of NaF. All right, so that's 125.6 divided by 42, and we get approximately 3, we'll just do it as 3 moles of NaF, okay? So this becomes 3.0 moles of NaF. So now we can solve for M1. So we got M1 is equal to N over V1. So that is equal to 3.0 moles of NaF all over 1 liter, which is equal to 3 molar NaF. So that's our first solution. Okay, now let's read the second question. We're going to take 180 milliliters of this solution, and we're going to dilute it to 500 milliliters. So our volume 1 is going to be 180 milliliters. Our molarity of 1 is what we just calculated, 3 molar NaF. We are going to dilute it to 500 milliliters, so our V2 is going to be 500 milliliters, and our M2 we do not know. So again, we can just use that equation, M1V1 equals M2V2. M1V1 equals M2V2. All right, so M1 is 3 molar. Our V1 is 0.18 liters. Our M2 we do not know, and our V2 is 500 or 0.5 liters. All right, and our M2 is now equal to 3 times 0.18 divided by 0.5, and we get 1.08 molar NaF solution. All right, so again, we're just doing basic dilutions. Again, you're going to see a little bit of dimensional analysis in here if you're given grams. You can use your M equals N over V if you're just solving for molarity, but if you're just diluting between solutions, this is a dilution equation. M1V1 equals M2V2. All right, that's another way. Again, right here, if you notice, I changed it to liters, and that's just because they cancel out. If you want to leave it in milliliters, that's fine too. It will work because they're on opposite sides of the equation, so they're just going to cancel each other out when you divide them. So again, it's kind of your choice. Practice with these. see how they do. This is basically how you're going to be dealing with it, solving for molarity, solving for volume. But overall, it's just using the same equation. Good luck, and I'll see you next time. Bye-bye.